Okay, hey guys, welcome to the world of Minecraft. This is Mrs. Longley, and what we're going to do today is we're going to have a little mini lesson over volume. And so keep your objective for the day in mind as we learn a little more about math. So here we go. So in front of us we have a glass enclosed rectangular prism. And what we're going to do is try to find the volume of that rectangular prism. And so when you're wondering what volume is, volume has to do with how much something can hold. So it's dealing with how many specifically cubic units an object can hold, or if it's a solid object that does not hold anything, then when we speak about its volume, we're talking about how much space it takes up in terms of cubic units. Now when I say cubic units, what I mean is, in Minecraft it would be these blocks, but a cubic unit is a unit of measurement that has length, width, and height, and all of them are the same. So a cubic centimeter would be a centimeter long, a centimeter wide, and a centimeter high. A cubic foot would be 1 foot long, 1 foot wide, 1 foot high. A cubic mile would be a mile long, a mile wide, and a mile high. So you can use any unit or any type of measurement unit, and as long as you use that same amount for length, width, and height, that would be a cubic unit. Okay, and since Minecraft we don't know the exact length, width, and height of these blocks, we're just going to call them either unit cubes, or you can call them cubic units. So right now what we're trying to do is see how many cubic units can fill the prism, and you'll notice that we already actually have it filled, which is kind of a problem. So let's empty this container. Ta-da! And there's my magic trick. So now my rectangular prism is indeed empty, and so we are going to replicate what you saw before. We're going to model that using our cubes. We're going to fill it, and then we're going to count the cubes as we fill it and try to learn something new about volume. So you're going to have to kind of look for a pattern here. So as I go into my rectangular prism, here we go. We are going to start filling it with unit cubes, and you can count along with me. Just be prepared for a few hiccups along the way, as sometimes when I am recording, the video goes a little slow and gets a little laggy. So yes, there might be some little mistakes here and there, so just bear with me. So how many unit cubes or cubic units are needed to fill the prism? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Aha! So, going back to our original question, how many cubic units can fill the prism? We needed 60 cubic units in order to fill this rectangular prism. So that is its volume. Volume equals 60 units cubed. Okay? So now that we know that, what I want to know is, let's see. Let me fill that. We're just going to use wool for now because who cares? So, thinking about that, if I create a new rectangular prism, and we call it a rectangular prism because it has a rectangular base, and it has 2 bases, not just one. So that makes it a prism. If it had just one base and it came to a point, that would be a pyramid. So everyone agrees that this is a rectangular prism. It's a little bit different than the one we were looking at before. In fact, I'm going to go ahead and add another layer just for the sake of making it a little bit more different. And I want all the dimensions to be different as well. When I say dimensions, I'm talking about length and width and height. So for volume lesson 2, is there an easier way to find volume? So going back to lesson 1, we had to fill the object with unit cubes. We had to fill them in order to find how many cubes there were to fill the prism. Well, what if we already have a rectangular prism and it's made for us, and I want to know how many cubes would be required to build up this prism? Then what I have to do is I need to think about the pattern that you hopefully noticed in this first prism, and we're going to come up with a rule, and then we are going to apply it to the second prism. So, just as a reminder, the dimensions of this rectangular prism were a width of 3, a length of 4, and a height of 5. Okay, a width of 3, a length of 4, and a height of 5. Now, yes, you can use length and width interchangeably, but I want you to consider that 3, 4, and 5. And then the volume itself was actually 60 unit cubed. So, I'm going to give you a minute to think about how could we use 3, 4, and 5 to get 60. And while you do that, it is getting dark out here, so I am going to go take a nap. Shh. Nap time. Okay, it is morning, so hopefully you considered how we could have gotten 60 units cubed based on some quick math. And so if you came up with, Mrs. Longley, multiply 3 for the width, times 4 the length, and then times 5 the height to get 60. Let's try that. 3 times 4 is 12, and then 12 times 5 would give me 60. So that does seem to work. Now, we don't know if it's an actual rule yet. We have to try it out a few more times and make sure that there's no reason for it not to work. So here we go. Let's try. Here we have you could either call that the length or the width, but it would be 2 units. And then we have 4 units for the other dimension. And let's see, I'm going to do 3 units for the height, okay? So here we go. We have 2, and we have 1, 2, 3, 4, and then for the height we have 3. So if the pattern we found in this first prism, length times width times height, is true, then it has to be true for all rectangular prisms. So I should be able to take 2 times 4 times 3 and get the volume of this diamond rectangular prism right here. So let's try that. What's 2 times 4? Should have gotten 8. And then 8 times 3 would give us 24. So our hope is that if volume really is length times width times height, then when I take apart this rectangular prism, I should get a volume of 24 cubic units. So I'm going to try that. First I'm going to get rid of these. Okay, and so 3 times 4, okay, times 2, those are the dimensions, gave me 24 cubic units. So I should be able to count 24 units as I destroy this rectangular prism. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Aha, so our units cubed for the volume of that prism was indeed 24 cubic units. So is there an easier way to find volume? I think so. Length times width times height to find the volume of a rectangular prism. Okay, moving on. Lesson 3. Well, how can I use what I know about area to find volume. So you'll notice that I have a platform here, and I'm going to build a rectangular prism on this platform, and I want you to see if you can notice anything specifically about this prism. We're going to try to look for a new pattern. Okay, so we know area is length times width. You know what, I'm not going to use the diamonds anymore. Let's change it up. Okay. Okay, so this happens to have a length 1, 2, 3, 4, 5, and a width of 4. So if I fill this entire bottom layer, I'm covering a flat surface, which we know is area, and so the units typically would be square units, but we're about to see that with volume it's going to be cubed units. So right here, my area of that flat platform is going to be 20 square units, right? 20 square units, because 5 across and 4 down, 5 times 4 is 20. Well, let's add another layer. So that's 5 again, 10, so this is another 20 units. I added another layer, and it's still 20 units. So now I have a rectangular prism that has 20 cubic units and another 20 cubic units. So I have 40 cubic units right now. Okay, so let's try adding another layer. So how many units, how many cubed units do you think we are going to have on this layer? Okay, still 5 by 4, so 5 times 4 is 20, so I have another layer of 20 cubic units. So now with 3 layers, I have 20, 40, 60 cubic units. Let's add another layer. I'm pretty sure you're starting to see the pattern. Okay, another 20 cubic units. So now, not counting the bricks because that was just my platform, I have 20, 40, 60, 80 cubic units. 4 layers with 20 units on each layer, and the 20 units came from the area of the base. So if I take the area of the base, which is 20, and I see how many layers I'm going to need, I can multiply 20 times 4 to get 80 cubic units, which is exactly the number of units I need for the volume of this prism. Of course, not counting that bottom layer because that was just a pedestal for my prism. Okay, so that means if I have a 5th layer, how many cubic units should I have altogether at that point? Okay, there is another 20 cubic units. So I have the orange layer 20, 40 for blue, 60, 80, 100. So now that's 20 times 5. Another layer. Now I have 20, 40, 60, 80, 100, 120. 120 units, which would be the same as 20 times 6. Well, you'll notice that every time I'm multiplying the layers, what I'm doing is I'm multiplying it times the height. The height right now, starting at the orange, is 1, 2, 3, 4, 5, 6 units high. So what I'm doing is I'm taking the area of the base, which we know is 20. And the reason I know it's 20 is because length times height gives me area. Length times height here is 4 times 5, which is 20 units. And I have those 20 units over and over again as I add more layers. So I have 20, 40, 60, 80, 100, 120. And so that 120 comes from taking the 20 times how many layers, or 20 times the height. And I could keep on doing this forever, and it'll always be true that every time, all I'm really doing is taking that same 20, that same layer of 20 cubic units, and I'm just stacking it on top of itself. And so all I do is take the area of the base times the height. That is another way to find volume. So can I use area to find volume? Absolutely. Take the area of the base times the height, and that will give you the volume of that prism. That makes sense because the area of the base is length times width. And remember, the original equation we came up with over here was length times width times height. The length times width can just be replaced with the area of the base because that's what that means. Okay, so you might be wondering, well, Mrs. Longley, I think I've got it, but let's extend it a little bit further and say, well, what about cubes? Cubes are special rectangular prisms where the length, the width, and the height are all equal. In fact, we spoke about that earlier when we were talking about a unit cube. Well, these are not unit cubes. These are cubes built with unit cubes. So this cube happens to have a length of 2, a width of 2, and a height of 2. So notice they are all the same. And so when you see this, you can follow the same exact rule of either volume equals length times width times height, or you can do the area of the base times the height, whichever one. But consider the fact that a cube has all edges the same size. So how is that going to change your equation? How is that going to change the way we use our volume equation when we're talking about cubes? So I'm going to give you a moment to think about that, and then we're going to try it out on all 3 of these cubes that I have built for you here. While you are thinking, I am going to take yet another nap, and I am going to actually, I am going to fly toward my nap because it's faster. Okay, so you are considering, again, what is it that's going to be special about cubes that may be different about rectangular prisms, or maybe just be special. Okay, so nap is over. Interestingly enough, you might even be able to say, Miss Longley, your lesson is taking days. And you would be right because we are in Minecraft and time goes faster here. Okay, so the question I ask you is, with cubes, how are things going to be different? Well, cubes are actually easier because as long as I know it's a cube, the dimensions are all the same. So all I have to do is take length times width times height, but that's going to be the same thing each time. This cube right here has a length of 2, a width of 2, and a height of 2. So all I'm going to do is do 2 times 2 times 2. Well, be careful here because a lot of students get a little mixed up. They go too fast. They automatically assume 6. Got to do it slowly, okay? Even though I know that this is easy multiplication, don't make the simple mistake of adding instead of multiplying. So we have 2 times 2 is 4, times another 2 is 8. 2 times 2 is 4, times 2 is 8. Okay, so this cube has a volume of 8. And that makes sense because if I look at it from the top, I know one layer is 4 units cubed, and I have 2 layers. So the area of the base must be 4 times the height 2 gives me 8. Okay, looking at this cube, it has a length, width, and height of 3. So what is its volume? Well, 3 times 3 gives me 9, and 9 times 3 is 27. Or you could think of it in terms of layers like we did before. You'll notice one layer is 9 cubes, and I need 3 layers to make this cube. So that's going to be 9 times 3 is 27. And then looking at our last cube, this one right here, it has a length, width, and height of 4. So I have 4 times 4 is 16. And then 16 times another 4 would give me 64. Okay? Okay. So another way to think of it is looking at the area of the base here. 4 times 4 is 16. So 16 in one layer, and I have 1, 2, 3, 4 layers going from top to bottom. 1, 2, 3, 4 layers. So 16 times 4. Okay? And that's it. So volume, it's very simple. Length times width times height. If you have a cube, those are all going to be the same, so it's just going to be the same number multiplied times itself 3 times. You can think of it as the area of the base times the height. And just remember, the volume is how many cubic units it takes to fill something, or how many cubic units of space something takes up. That is it for today's lesson. So I'm going to go back in my house, and you are going to turn your attention back to the real Mrs. Longley, the one that exists inside the classroom and is not just a disembodied voice.